Hello and welcome to Connected Voices. I'm your host, Jared VanAllen. We're pleased to have a new episode of Connected Voices beginning today. We call it Meet the Geek. Joining us today, my favorite geek, Jim Electroman Baker, our senior electrical engineer, as well as the developer of many of the products that you see in terms of our power systems within the Ventev product line. Today, we'll be talking through some of the specific technical details. This is a little more technical overview in relation to some of the questions we get about, in this particular case, one of our solar systems. Welcome, Jim. How are you, Electroman?
I'm doing great, Jared. How are you?
I'm wonderful. Apparently not as hot as you because I'm not sitting outside.
Very true, very true.
Jim, we get a lot of specific technical questions in relation to our solar product set, which you're standing in front of a couple of examples of today in our outdoor location close to our distribution center. Jim, what are some of the questions that you get from customers on a more technical level for those products?
Yeah, so we're standing right next to our Wi-Fi solar enclosure system. This is used to pilot Wi-Fi access points up to 30 watts worth of power. So some of the questions we get is, well, why is the array size so big? A lot of people go through their neighborhoods, they see solar enclosure solar power systems on their roofs, and they're going, well, why do I need something so big? Well, it's actually twofold. One is the solar array actually has to charge the batteries. So whatever we take out during the evening when there's no sunlight, we have to go through and put back into a battery. The second reason is the numbers of days of autonomy, or how long the solar system has to power the access point when there's cloud cover in the area. We typically go through and we will power up for 5 days worth of autonomy. So the next day, upon the sixth day, when there's sun out, the array has to be able not only to run with the load, but it also has to go through and power up the system and fully charge. It's kind of like a bucket with a hole in the bottom. Okay, if you want to go through and have water in the bucket, you have to make sure that you pour enough water in to keep the water, maintain the water level as the water is draining outside of the bucket.
That makes a lot of sense. So again, just me recapping it the way I would look at it, I got to have a big solar panel sitting out there because I got to be able to run the device and charge my battery back up after a period of time where it's been relying on the battery to serve that intelligent device, correct?
Correct.
Great. So, Jim, that answers the question of why so big. Now, again, that system is designed to hold up a 30-watt PoE device for 5 days of autonomy. That's a long time, right? What are some of the other questions that come in regard to that specific setup or some of our other solar support systems?
Okay, one of the other questions we get is, what do I get in my kit? So it's like they sit down and say, well, is this something I'm going to have to buy additional parts to? Is this something that I get all in one? How does it come? Well, we actually go through and we supply a whole kit of parts so that your system will come with the panels, the mount for the panels, all the cabling that attaches to the panels, to the enclosure itself, plus the batteries that come with the system. So It's basically, in old-fashioned terms, it's a Heath kit. So you get to go through and get everything you need for one site to go through and actually have it. So once you assemble it, all you need to do is add the access point and the cat cable to go from the access point to the PoE injector inside of the enclosure, and you're all set, ready to go.
That's great. So about as turnkey as you can get in that type of a solution.
Correct.
You mentioned the PoE injector. Do I have to use the PoE injector on that system, or is there another way that I can power devices on that particular system?
Okay, there's actually two different devices. So if I can go through and walk into and show you inside the enclosure. Okay, there's a couple of different ways that you can go through and you can actually power it. One is the PoE injector. And what makes our PoE injector unique is that the PoE injector will take 12 volts DC and actually upconvert it to 56 volts DC over PoE. Okay, that allows us to go through and use a 12 volt system. Now, why is that important? Because if I have to go through and use a 48 volt solution, my battery bank that's here to supply power for 5 days, instead of 2 batteries that are in parallel, I would actually have to have 8 batteries in parallel to get it up there, because now my system would have to be 48 volts. Okay. The other way that you can go through and power it is if your access point can do 12 volts directly, then I can go through and connect to the DC terminal blocks here that are fused, so I can go through and operate it directly off of 12 volts.
Awesome. Awesome. So a lot of different options. Well, at least a couple of different options in terms of deploying equipment. I also noticed there's quite a bit of room in that enclosure that setup allows for mounting of gear inside that enclosure.
Correct. So that's leads into another question that's asked of, well, what can I actually put in the box? Okay. And basically, as long as you don't violate 30 watts at 12 volts, you can put anything that you want inside of this box that'll fit on the DIN rail.
That's awesome. You know, it brings up an interesting question, though, in terms of the batteries, Jim, and I notice a device sitting in there. How do these often are deployed in some pretty remote areas or somewhere I may not be walking by and checking them on a regular basis, and of course batteries over time degrade. How do I watch those batteries? How do I monitor them to ensure that they're functioning correctly without actually having to roll a truck into the middle of nowhere?
Okay, we have this device that you were referring to, which is the BTRM 300. The BTRM 300 is specifically designed for solar enclosure systems. It can handle up to 20 amps worth of power going through to the system, which pretty much the system that we're in now is the maximum that it can handle. But what this allows us to do is this allows us to go through and monitor the system remotely. So each BTRM has a built-in web page so that you can go to the IP address of that unit and tunnel in so you can see what is going on actively with the system. You can also have SNMP traps where you can go through and set up traps so that you can say, oh, if my voltage is low, it will go through and the system will catch that and then send you a notification that, hey, your battery is low. This also allows us to go through and test the batteries. And what's unique about this system as opposed to other systems is this will go through and actually test under load. So it'll shut down the solar panels and the charging that's happening to the batteries, and it'll run the test while the load is being powered. Why is that important? Well, it's because you want to go through and actively see what the batteries can handle. A lot of different other systems out there will monitor the batteries, but they'll simply monitor battery voltage. They won't actually monitor current under load. And the difference there is essentially going out to a car in the winter and putting your key in the ignition and turning it and nothing happens. You go out and you look at your battery and measure the voltage and say, hey, I still have 12 volts. Why won't my engine turn over? Well, that's because there's not enough current to go through and engage the starter to turn on the engine. It's a similar situation. If you can have voltage here on the batteries, but if you don't have current to go through and actually operate the load, then your load is not going to work when you think it should work.
It's not going to start my radio up. Got it.
Correct.
All right. Well, thanks for that explanation, Jim. And the BTRM, the battery test remote monitor, is kind of self-explanatory after that in terms of why we call it the battery test remote monitor, or BTRM.
Correct.
All right, Jim. So I run into a lot of situations where a customer will say, well, I need to power something larger than 30 watts.
Okay.
Do we do that?
Yes, we can. So we have larger systems, and what I'll show you next is basically a 60-watt system. This was specifically designed for utility to go through and operate, again, an access point, but this time they didn't want the 5 days that we have on our existing system. They wanted to have 8 to 10 days because they were actually a critical deployment where they were using it to go through and they needed to record information and they needed to guarantee that they could record that information, and they did not want to have any questions as to whether their access point was up or down. They wanted it to constantly work. And this was actually in the Appalachian Mountains, down south of Baltimore. So we designed this system. And as you can see, it definitely is a step up. So we have 3 panels instead of the 2. The panels are actually a lot larger. This system is working at 24 volts DC. And our enclosure is a lot larger as well because you needed a lot larger battery bank for 2 reasons. One, now you're talking 24 volts, so you have to actually go through in series, go through and put your batteries to get 24 volts, and then it needed 2 banks to go through and get me the 8 to 12 days worth of autonomy. So I needed 2 sets. So this actually has 4 sets of telecom batteries in there that are 170 amp hours a piece. So it's actually 340 amp hours for each 24 volt battery bank.
Great. That's awesome, Jim. And that at that point, we're kind of stretching the limits of what I can put on a pole, though. I mean, given the panels themselves, but really by the time I'm getting to that big of a system, I'm kind of stretching the limits of what I can mount to a pole for the enclosure and the rest of it. Is that true?
Yeah, you're getting close to what we call you need a pad mount thing. So as you can see on this particular enclosure, for our system, we have a 3.5 inch pole that's actually holding the system up. And then we have a non-PEM mount with cinder blocks to go through and stabilize things. Um, but anything really that starts getting larger than this, you're going to probably have to talk about a bigger pole, potentially a utility pole, or if you still wanted a aluminum pole, you can get it, but now you're going to have to pour a concrete pad and bed the pole into that concrete pad. So our maximum system at this time is 90 watts, which you can still have on a pole, but now instead of a side of a pole mount kit, you actually have the top of a pole mount kit where you actually have your array mounted at the very top of the poles so that you can distribute the weight accordingly. And then you have that system that's sitting at the bottom of the pole.
Got it. Got it. Well, that gives a pretty wide variety of kind of devices that we can facilitate with solar. Given solar gets pretty big pretty fast as you start trying to support some of the larger devices, but in terms of supplying a radio, an access point, a point-to-point or point-to-multi-point, other types of implementations, non-PoE switches, things of that nature, that's a pretty varied system. And you bring up a good point, Jim. We do have our standard systems, and they fit the majority of implementations that customers come to us with. But we also have the ability to do a little bit of customization within that window of products. And as long as the business case makes sense, be able to build something like we did there for that power company in Appalachia, correct?
Correct. There's a couple of things you have to keep in mind. First of all, we need to know what the duty cycle of the radio is. So we need to know when you transmit, when you receive. And the reason why that's important is when you're transmitting, you're going through and taking up more power on the radio. And when you receive, you're just kind of sitting there listening to what may be going on. Okay? So that's important so we can do the sizing. The other part of that is, how many amps do you draw, which the duty cycle plays into. Because you got to remember, if a device draws, say, 1 amp, okay, that's 1 amp per hour. So now you have to multiply that by 24. So now I have 24 amps per day. And then depending on how many days of autonomy you want, you have to go through and you have to multiply that by the number of days. So if we keep it simple and say, I want 4 days worth of autonomy, now you have to support 96 amps for that 4 days, which means your battery bank has to be able to go through and support that for that number of days. Your solar array has to be able to put that back in to your batteries in 1 day, and your solar controller needs to be able to handle all the current from the solar panel in that 1 day. So all of that factors into customization of your design for a solar enclosure system.
Great. Thanks, Jim. And basically, that's the information we need anyway, whether it's within the standard product set or potentially a little more custom solution where it's appropriate. And that is, what device am I powering? What's its draw? What's its duty cycle draw? How many days of autonomy you're expecting? And where are you actually putting the thing physically, right? Did I miss anything on the list of stuff we need to know right off the bat?
No, but I want to emphasize it's key for the location of it. We basically need geographic coordinates to go through and place that, which is very important because the solar radiation patterns change as you go through and progress basically around the globe. So we've done stuff not only for the continental United States, but also for the continent of Africa. We've gone through and done sizing for Australia. We've done sizing for Canada, but it all depends on where you're placing it so that we can go through and see what the solar radiation pattern is, so we can determine how much solar radiation is hitting in that area. And also we need to know temperatures so we can do temperature compensation of the batteries to guarantee in extreme temperatures your system is still going to work.
That makes a lot of sense. And then, of course, that becomes just that much more important as we look moving forward at potentials like lithium chemistries, et cetera, as we move forward, correct?
Correct. And currently, right now, we're taking a look at lithium products to go into our systems. So as we're speaking now, I'm actually going through testing that's going to probably take 4 to 5 months to get through, but we're actually going through and testing those batteries under load to make sure that we select the correct controller and we have the correct battery sizing for those systems.
Well, you bring up a very important point, Jim, in terms of how we do our systems that differentiate them. Number one, they are engineered systems. They're not just thrown on a panel shop line with an expectation that they somehow come out right. Thus, our utilization of Electroman and his ability to actually do math, which is hard. Math is hard. Let's face it, Electroman. And then the fact that build consistency is then a result of that. So you get the same system today that you get 3 years from now. And we put it through the rigorous testing before we ever throw it onto the market to make dang sure that we have that consistency and that reliability going forward. Is that a fair statement, Jim?
Yeah, and that's why out in our patio area, we have this solar farm that we can go through and perform those testing on.
And by the way, it's there in Baltimore where we had some tornadoes roll through just a couple of weeks ago. So, we know that it it puts up with a lot of abuse. All right, Electro Man, thanks for joining us for our inaugural rendition of Meet the Geek. Jim, it's always a pleasure working with you. I learned so much from you. I want to thank you from the bottom of my heart for all of the time and energy you spend with me. Thanks for showing up today. And thank you all for joining us with Connected Voices.